Now, the last thing that we need to do is, because your run.py can also have dependencies, you can define a conda.yml file using which your run.py can run. And to avoid the inconvenience of creating or activating this conda environment, we can also create an ML project. Now, as far as our current Python file is concerned, which is run.py, it in itself does not accept any command line arguments. In fact, it accepts the configuration coming from Hydra. And for that, there is a little bit of syntactic sugar that we had to use while defining our parameters and run command. And that's the only change we needed to do. Now, if I run mlflow run dot, it'll execute this run file in the appropriate environment in which that run file can run. In case you have dependencies and you might forget how to keep track of them, MLflow or MLproject will help you keep a track of things. Now, what this will do is this will, in an appropriate environment for the run.py file, run the run.py file, and then the run.py file will run each of these components in their appropriate environments with the appropriate configurations. So this completes our discussion on creating a training pipeline. Now you can very easily see the benefits of it. If you need to probably run this pipeline again and there's a different source of data, you can just probably change that path over here. And if you need to train your model with different hyperparameters, you can probably change those hyperparameters over here. Now what remains to be discussed is, how do you record at each model run? What was your accuracy? What were the hyperparameters used? What was the training data used? And how do you save the trained model? That is something that we're going to discuss in the next part of a couple of videos that I've created.